Alright, welcome back to another lesson here with our geometry class. We are going to be looking at distance as a review for a warm-up, and then our lesson today will be on the midpoint formula. So I have a couple practice problems here from review of the distance formula. I'd like you to go ahead and give these a try. Go ahead and pause your video now, and we will have you work through these two problems. When you come back, we will have the examples of how to complete both of them as a group. All right, so looking at this first problem, we have 8, -4, and 12, 7. We would label 8 as x1 and -4 as y1. You would label 12 as x2 and 7 as y2. Now that we have all of our values labeled out, we will put them into our distance formula. The distance equals the square root of x2, which is 12, minus x1, which is 8, squared, plus y2, which is 7, minus y1, which is -4. And that one is squared as well. So as we work through this, again, we have distance formula the distance equals 12 minus 8, which is 4, squared, plus 7 minus -4. This -4 and the negative together become a positive, so we get 7 plus 4, so we get 11 squared. And 4 squared is 16. Plus 11 squared is 121. Remember, at this step, all of our numbers should be positive. If we have a negative number at this step, we have done something wrong. Go back to those squares and make sure we include the parentheses. 16 plus 21 is 137. So we have the square root of 137. And I take the square root of that, and I am rounding to the 10th. It is 11.7. Looking at this next example, we have x1 as 15, y1 as 9, x2 as 22, and y2 as 16. Plug these numbers into my distance formula of d equals x2 minus x1 squared plus y2 minus y1 squared, and I get 22 minus 15 squared plus 16 minus 9 squared. I do my two subtraction problems. I get 22 minus 15 gives me 7 squared, plus 16 minus 9 also gives me 7 squared. 7 squared is 49, so I have 49 plus another 7 squared, which is another 49. So I have the distance equals the square root of 98. And I get distance equals, now when I do this problem, I get 9.89. So I round this to 9.9. If you have any questions about distance formula still, we can speak next time in class in person. So today we are going to be working through the midpoint formula, and we're going to start with a definition of the midpoint. And the midpoint midpoint is the halfway. The halfway. You have made it halfway there. The halfway point between the endpoints of a line segment. In other words, it is the middle of the line. It cuts it into two equal parts. And the midpoint itself can be broken down into two parts. The x value of the midpoint and the y value of the midpoint. The x value of a midpoint is halfway between the two x values of the endpoints. And the y value of a midpoint is halfway between the two y values of the endpoints. So we're going to go over a visual example of this right now. We're going to go over a visual example of this to make sure that you guys can see this. So our example has endpoints of 2, 2, and 10, 6. And that is already drawn on the graph. So what we're going to do, we're going to just kind of connect our dots there, and there, and then go the other way. And now I have two different lines to look at. I have a red line, or 2 points between the red lines here. Make a line, and the two between the blue line, the blue dotted lines. So now I can find out how long each of these are. The x length was from 2 to 10, so that makes this an 8. The y values were between 2 and 6. 2 and 6, so they are 4. It has a length of 4. Now, our next step is to go to the middle of the x value. And remember, when we are trying to find the length of a line on a graph, we are going to count each square starting at the first point. 1, 2, 3, 4. Same thing over here. 1, 2, 3, 4, 5, 6, 7, 8. And now what I need to do is find the middle of the x value and the middle of the y value. So if I go to the middle of the x value on my blue line here, 8 is all the way. I have to cut that in 2, so I would go to 4 over. 1, 2, 3, 4. And this is going to be my x value. It was at 2, 3, 4, 5, and 6. The x value is 6. And then I'm going to do the same thing for the y value. 4, half of 4 is 2. 1, 2. I'm right here. And I started at 2. This will be 2, 3, 4. So my y value is 4. And now I need to set those into a ordered pair, which remember is always x then y. So my midpoint is 6, 4. If I go to 6 over and 4 up, 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, I end up right here at the midpoint of my line segment. So go ahead and pause the video at this time and give these two problems a try on your own. Find the midpoint using those steps we just used. All right, so again, we are going to make lines from each point going to the x-axis for each point, and the y-axis for each point. Then I'm going to look at how long each one is. From blue to blue, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It is 10 long. And for the red, we're looking at, for the Y, 1, 2, 3, 4, 5, 6. 6. So now I will count halfway for the blue. If it is 10, halfway would be 5. So I'm going to count 1, 2, 3, 4, 5. And I'm at -1. And now for the red, or the Y, I will count half of 6, which is 3. 1, 2, 3, I'm at 0, so y of the midpoint equals 0. I'm going to convert those into an ordered pair and get -1, 0. When I go to -1, 0 right here, I'm at my midpoint. Let's try it one more time. -6, I'm at 8. Count those, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I'm at 1 and 3, 1, 2, so I have 2. I take half of 14, which is 7, so my x value for my midpoint will be 7 over from either of the endpoints. 1, 2, 3, 4, 5, 6, 7. I'm at 1. And for my y value, half of 2 would be 1, so 1. And I'm at 2 for the y value of the midpoint. So now I put them together as an ordered pair. I get 1, 2. So I come over to 1, go up to 2, and this would be my midpoint right here. So the midpoint of a line segment can also be found using the midpoint formula. And this does not require a graph when we are using the midpoint formula. You only need the endpoints. So this here is the formula. It says that the midpoint of a line segment is x1 plus x2 divided by 2, and y1 plus y2 divided by 2. So, looking at this, we are going to label the points in the same manner as with the distance formula. So we get 0.1. I'm going to put a box around. 0.1 is going to be in blue. Put a box around 0.1. 0.1 gets my x1, my y1. But for now, 0.1 is 4, 8. And 0.2 would be the second point. And it will eventually become x2, y2. For now, we will make sure that we put it down here as negative 6, 2. So now we get to label them up like we just did, x1, y1, x2, y2. And now we are going to substitute those values into our formula. So wherever I see x1, I put 4. So this says that 4 plus x2, which is negative 6, 4 plus negative 6 divided by 2 and y1, which is 8, plus y2, which is 2, divided by 2. And now what we're going to do is we're going to solve for each one individually, and then bring them back together, just kind of coming down as we go. So first I would do 4 plus negative 6, which gives me 2. So now I've got negative 2 divided by 2. This will become 1. And now on the second part, for the y value, I have 8 plus 2, which will become 10, divided by 2. 10 divided by 2 gives me 5. Now, at this point, if you go to solve and you do your value divided by 2 and you get a decimal, that is okay. Leave it as a decimal. If you get it as a mixed fraction or as a improper fraction, you can leave it as an improper fraction as well if you know it will not be a whole number. And so as we see here, we kind of did each one down and then we put it back into a coordinate, in our new coordinates into an ordered pair. I'd like you to try these next 3 on your own. And when we come back, after you have paused it and worked through these 3, we will come back and do them as together as a group. Please pause the video and give this a try. Okay, looking at this first one, we label our first point that we see as x1, y1. Second one as x2, y2. We put it into the formula, and we get negative 3 plus 4 divided by 2, and we get negative 9 plus 12 divided by 2. We're going to work through the x first. Negative 3 plus 4 gives me 1. So I get 1 divided by 2. And I cannot bring that any smaller, so that is going to stay either 0.5 or 1 over 2. Now I'm going to work through this next one. I get negative 9 plus 12. I'm going to get 3 over 2. 3 over 2 is 1.5. I can write that as 1.5. Either one of these would work. These are both a correct answer here and here. Due to the fact that they're mixed or an improper fraction or left in fractions, because they do not become whole numbers, we can leave them in fractions or we can put them into decimal form. Looking here at this next problem, endpoints of 7, 3, and 13, negative 2. We label up x1, y1. And we plant them into our formula. So I have 7 plus 13 divided by 2, and 3 plus negative 12 divided by 2. 7 plus 13 gives me 20 divided by 2. 20 divided by 2 gives me 10. 3 plus negative 12 gives me negative 9 over 2. I could leave that as negative 9 over 2, or I can turn it into 4 and a half. Negative 4 and a half. And our last example here, using some larger numbers, but the process is going to stay exactly the same. We would start with labeling x1, y1, x2, y2. So we get let me keep this format the same. 25 plus 43 divided by 2. Set up the second part as 18 plus 34 . 18 plus 34 divided by 2. 25 plus 43 gives us 68 divided by 2. 68 divided by 2 gives us 34. 18 plus 34 gives us 52. And 52 divided by 2 gives us 26. Thank you for watching and taking notes. We will be working on midpoint in class next time we see you. The next video lesson will be on slope. And then we will bring distance, midpoint, and slope all together. Thank you for watching and have a wonderful day.